Now in last video, you saw the problem which we were facing because we were not using the multi-threading. So what was the problem? The problem was that main thread was executing down and suddenly it encountered a task which is taking long time. Okay. Now due to this, the other code which are written down to this is also not executing. Why? Because our execution got stopped here. So this piece of chunk of code will execute only when this whole thing gets processed and executed. But now this thing is taking suppose that 5 minutes of time, then unfortunately we have to wait for the 5 minutes. So the solution was ki let the main thread keep going, and when it encounters this big task, it creates a new thread here, new thread, and it gives that task to this thread. Now bro, now it's your responsibility to do this task, and let me do my other task which I am doing. This main will tell to this thread. So basically it will keep going down to execute the other task, and this new thread which is created now has the responsibility to do this big task which is taking a lot of time. In this way, two tasks, two processes, means it's not process, but two concurrent threads are running. One is main thread, another is the new thread which we have created, and they both are doing their work. In this way, we are saving some of our time definitely. So there are two ways to create the thread. Other is by extending a thread class, and the another is by implementing the runnable interface. Now the preferred way is by implementing the runnable interface, because if in the class you are extending the thread class, you cannot extend some other class because Java does not support the multiple inheritance. So that's why the preferred way is that create the thread by implementing the runnable interface, because in that case you can extend some other class also, and who knows, you need that. So that's why the preferred way is by implementing the runnable interface. Now I'll go to the same problem and I'll explain you that how we can solve that problem by creating a thread for that specific task which is taking a long time to execute. So let's go to the code. Okay, now this is our code. So what we are doing here, that these two lines of code basically is taking a lot of time because because of something, because it is looping there and it is sleeping for some time on each and every loop. So now we want to create a different thread, a new thread from here, so that main thread and this thread, the thread which we create here, will execute concurrently and our work will be done faster. So how to do that? How to create a new thread? So now we will use extends thread way to create a thread. So let's see how to do that. Now this is our class where we have written this chunk of code which is taking a lot of time to execute. And now we want that these things to be taken care by a different thread. So what we will do, we will simply write extends and then thread. Okay. So what we will do, that this class which was not extending anything, we will make it extends thread class. Okay, and now this was an ordinary function. We will rename this function and we will make it run. We will rename this function and we will rename it to run. This run function is basically function which is getting overridden here in this class. This run function is basically is in thread method also, and we are overriding it. So when we do this, what happens, that as soon as we create the instance of this class and we write start, a new thread gets created magically. So what happens basically, now this is not just an ordinary class and it's not just ordinary method. Why? Because see, we are calling start method from this class, from this object which is of this class. But you see, we do not have any start method here. No, we do not have. But then when you invoke the start method, flow exactly will come to this run method which is in this class. So what is happening basically is that a new thread is getting created, and when you invoke the start, it is going to the run method of this, and it will do this task parallelly. And since we have given this whole task to a new thread name is multi, this multi-thread will keep doing that tedious task, and the main thread will keep doing this task. You want to see? Let's execute it. So now you see I'm executing. What happened? Fine. See the magic. I think you have not realized the magic. I'll show you. Don't worry. So what happened? That first main got printed. Okay, why? Because we are printing the main, and then CSC body we are printing 3, 4, 5 times. That is 1, 2, 3, 4, 5 times. But hey, why this again coming 1, 2, 3, 4, 5 times? And then this thread part is coming. So basically what is happening, that main thread now is not waiting for this. So what main did, main printed this 5 times, and main again printed this 5 times. So that's why you can see 10 times CSU body on the top. And main created a new thread name was multi, and it told that bro, now you take care of the task which is happening in this class, basically which the code which is written in run method. Now you take care of that, that is taking a lot of time. You do it parallelly, and in meanwhile let me do this thing. So that's why main got completed this work. So that now see, main is no more waiting for this task to get completed. It went directly downside and it completed each and everything. And now this thread, you can see it is written thread 0. Thread 0 means since it is getting created first time, thread 0 is running and it is doing its task parallelly. So that's why we have created two parallel threads. One is main thread, another is this thread. Thread name is whose name is right now thread 0. Okay, thread 0 is the name of that thread. We can also change the name of that thread by doing multi dot set name. Set name you can say T0. Now when you will execute it, now instead of thread 0 it will come as T0. Why? Because when we are invoking start, it is going to the run method, and in run method we are looping and we are getting the current instance of thread by thread.current thread, and we are asking that what is the name, and the name we have set there is T0. So that's why every time it will be printed T0. So this is how multi-threading is helping us by providing a concurrency to our application. Now I'll also want to tell that when we have written this new keyword, basically this is the new stage. As soon as we write the new, this is the new stage of the thread. And as soon as we invoke the start method on it, when we are invoking the start method, then this is the when we do the start, then this is basically runnable phase. You see the runnable phase, it comes after invoking the start method. So as soon as we invoke the start method, this is the runnable phase. What it means? It means that we have submitted this thread, okay, and as soon as the scheduler is free, means as soon as our CPU is free, the scheduler will take this thread and will put it into the run method. Now where is run method? Run method is here. So if the code flow come here, this is called runnable phase. Okay, so this is called basically the running phase. Why? Because now our thread is running. Okay, and when this all thing will be completed, when it comes out from the run method, this is called terminated phase. And see, when we are sleeping, then this phase is called blocked phase. blocked phase. Okay, so now I showed you the entire phase, entire stages of a thread. So this is the new thread when we are new phase, when we are creating the thread using the new keyword. And as soon as we invoke the start method on it, it goes to the runnable phase. Runnable phase means it is not running right now, but it is able to run. That means if the scheduler will put this thread into the run method basically, that is to the CPU, it will go to the run method and it will come into the running phase. So it is it is able to run, and when it goes to the run method, it comes to the running phase. And when you invoke the sleep, that means that you are telling that this thread to sleep for some time. This is the block phase. And when it comes out from the run, it is the terminated phase. So the key point to note here is that we first extend the thread class to any ordinary class, and that's how we make a thread. So you can give the power of multi-threading to any class by just extending the thread class. You just invoke the thread class and just extends the thread class, make a run method there in that class, and in that run method only you write your entire logic. And then as soon as you will do start, you will invoke the start method on that instance. It will basically create a new thread here, a new thread, a parallel execution will start from here. So this is how the multi-threading is done by extending the thread class.